Hello. This video is part of a series of videos that deal with all the topics you need to know to get a grade E at GCSE. In fact, if you get all the questions right at grade E or below, you might end up with a grade D. This one deals solely with the topic of number. Now, before I deal with that in greater detail, obviously you'll be more interested in a grade C or a higher grade. And later sets of videos will deal with the additional topics you need to know at grade D and grade C. Now, use this video as a memory jogger. If a topic comes up that you're unsure about, then make a note. And then later on you can either do some research and find a more detailed video, or you can go to your teacher, or you can get in contact with me and we could do some online tuition. Anyway, let's now begin with the mathematics. Now, I've divided the topic of number into three parts: the very basics, changing numbers, and contextual problems. Let's deal with the basics first. Now, the basics, we're going to deal with integers, that's whole numbers, negative or directed numbers, decimals, fractions, ratios, and finally indices, roots, and we'll look at BIDMAS. Now, let's look at the very basics. I'm going to assume that all of you can add and subtract single-digit numbers. Now, I better just explain what a single-digit number is. It's a number like 7 or 3. It's only got one digit or figure. Now, multiplication, I'm again going to assume most of you know your times tables. But let's look at in a little more detail at multiplication. 5 times 8, well, that's 40. Now, I'm going to use the terminology of mathematics, perhaps more than some teachers do. This number 40 is a multiple of 5. Why? Because 40 is in the 5 times table. You get it by multiplying 5 times 8. Let's look at division. 12 divided by 2 equals 6. Now, what does that mean? That means that 2 is a factor of 12 because it divides exactly into 12. There's no remainder. The answer is 6. Now, let's have a look at multiplication, addition, subtraction, and division involving 2 or more digits. Let's look at long addition. Here we go. Let's say you got the question 234 add 87. Right, the first thing you do is you write it down in column format. Use the squares if you've got them, though of course in an exam you won't have squared paper. Now, watch what I do. Before I start doing the arithmetic, notice that the units, that's the last figure of each number, line up. And then all the other numbers line up to the left. Now, watch what I do. 4 add 7 is 11. Now, I can only write one figure in a square. So I put the 1 there, and I carry the other one that's part of 11. 3 add 8 is 11. Add the carried 1 is 12. Again, I write down the last figure of 12, 2 there, and carry the 1. 2 add nothing is 2, add the carried 1 is 3. Then underline it, and there's our answer. It's 321. Let's look at subtraction, which is just slightly harder. Let's just get rid of this stuff here. Right, let's say you're asked to find 360 take away 147. So again, we write it down in column format. So we make our last figures, the 0 of 360 and the 7 of 147 line up. Put a line underneath, put a minus sign there in case we get distracted. Now, watch what I do. I start from the right. 0, take away 7. Well, you can't do it with this method, so I have to borrow 1 from the figure to the left of 0. So that 6 goes down to 5, and I put a 1 in front of the 0 to make it 10. Now I do this. 10 take away 7 is 3. 5 take away 4 is 1. 3 take away 1 is 2. And then, because we like to be neat and precise, we put a line there, and here's our answer. 360 take away 147 is 213. Right, now let's look at multiplication. It gets a bit harder. Well, for some, if you don't know your times tables, we're going to do 78 times 26. So we write down 7, 8 times 26. Notice I've lined up the figures again. Now watch what I do. I start with the bottom number to the right. So the bottom number, the rightmost bottom number is 6. I do 6 times 8. 6 times 8 is 48. So I put 8 there and carry the 4. Next I do 6 times 7. 6 times 7 is 42. Add the 4 carried is 46. I put 6 there, and I would carry the 4, but as there's nothing going in there, I've multiplied both the 7 and the 8, I can straightways write that 4 in that square there. Now, what do I do next? Well, next I'm going to multiply everything in the top, every figure in the top number by 2. But because the 2's in the tens column, I start with a 0 first, and then I do 2 times 8, which is 16, put the 6 there, carry the 1, then I do 2 times 7, 14, add the carried 1, 15, put 5 there, would normally carry the 1, but there's nothing going in this square here, so I'll write the 1. Now I haven't quite finished. Next I add up these figures. 8 add 0 is 8, 6 add 6 is 12, put the 2 there, carry the 1, 4 add 5 is 9, add the carried 1, 10, put the 0 there, carry the 1, nothing add 1 is 1, add the carried 1 is 2, and there's our answer. Two, 0, 2, 8. Let me put a comma every 3 figures from the right. Okay, let's try one more. This time we're going to look at division, and we're going to do 685 divided or shared 4 ways, divided by 4. Now, when we do division, we draw a little bus shelter type symbol. Inside it goes the number I'm dividing, and outside it goes the number I'm dividing by. Now watch what I do. 4 into 6. 4 goes into 6 once, remainder 2. 4's into 28. Go 7 times, no remainder. Then 4's into 5 go once with 1 remainder. So I'll write that answer as 171, remainder 1. And they're the basics. Now you need to know these before you can go any further. Right, let's now look at the second one I mentioned, which is directed negative numbers. How do we get them? What are negative numbers? Well, here we go. What's 8 take away 5? Well, it's 3, because the number I'm taking away, 5, is smaller than the number I'm taking it away from. But how do we get negative numbers? Well, we get them when the number we're taking away, in this instance 8, is bigger. 5 take away 8 is minus 3, and that's where negative numbers came from, when you take away more than you've got. Right, so let's look at some of the questions you might come up against. Now remember, this is just a memory jogger. Minus 2 take away 8. So it's already minus and you're taking away 8. Well, the answer to that is minus 10. You're making it more negative. Let's look at another one. Minus 6 add 5. So you've got a negative number and you're adding to it. Minus 6 add 5 is minus 1. If you don't know how to do that, I say look up negative numbers. Let's look at another example of the sort of questions that might come up. What about this? 5 add a negative number. Now, whenever you get 2 symbols with nothing in between, change them to 1 symbol. And the rule is quite simple. If the 2 symbols are different, then you change it to a negative symbol. So 5 add minus 1 is the same as 5 take away 1, which is 4. Let's look at that again. Minus 3 add minus 4. Again, we've got 2 symbols with nothing in between, and we would change those to 1 symbol, and that symbol is minus. Minus 3 take away 4, you're going to make it more negative, is minus 7. Now, what about this one here? 5 take away minus 1. 2 symbols with nothing in between, we change two symbols where they're both the same and there's nothing in between, to plus. So that becomes plus 1. 5 add 1 is 6. Let's look at one more then. Minus 3 minus minus 4. Two symbols that are the same, so we're going to change those, aren't we? We're going to change those to plus. Just get rid of a little bit there. Minus 3 add 4. It was minus 3, then you're adding 4. It's going to be plus 1. You don't have to put the plus sign in when the answer is positive, but it's not bad practice. Right, so that's looking at adding and subtracting negative numbers. Now we'll look at the easier one of multiplying and dividing them. Here we go, let's look at some. 4 times minus 5. Here's what we do. You multiply the number parts together. 4 times 5 is 20. And then you put any symbol that was involved in front. So the answer is minus 20. Let's go through that again. Minus 3 times 2. So multiply the number parts together. 3 times 2 is 6. What symbols were involved? Well, there was just the 1. It was a minus. And we put that in front. Let's look at this example. Minus 6 times minus 2, where we've got two symbols. So you do 6 times 2. That's the easy bit. Is 12. And then what symbols were involved? Well, there was two of them. There were two of them. Two minuses. Now, same rule as before. If you've got two symbols with nothing in between, and they're the same, we change it to plus. So the answer is plus 12, or of course you could write it as just 12. What about division? I haven't looked at that yet. 8 divided by minus 4. Well, you do 8 divided by 4, which gives you 2. What symbols were involved? A minus sign. So it becomes minus 2. Let's continue looking at division. Look, minus 8 divided by 2. 8 divided by 2 is 4. There was one symbol involved, and it was a minus, so the answer is minus 4. And finally, let's look where there's two symbols involved. Minus 10 divided by minus 2. So we do 10 divided by 2. Let's get the number part of our answer right. 10 divided by 2 is 5. But we've got two symbols. So we write those two symbols. Two symbols with nothing in between. If they're the same, they become plus. Right, I'll just pause there. Hello again. Right, now, just before we move on to decimals, there's one other thing we need to do. We need to be able to order numbers. Let's look at this list of numbers. And we're asked to put them in order, the smallest first. Now, whenever you've got a list of numbers, some of which are negative, some of which are positive, remember, a number without a sign in front is positive. Look at the negative ones first. Now, the bigger the number to the right of the negative sign, the smaller it is. So our smallest number is minus 10. Then it's minus 6, then minus 3. Now, the last two we've got left, plus 1 and plus 4, shouldn't be a problem, should they? Plus 1 is smaller than plus 4 being the largest. So there they are in order. Okay, now let's look at decimals. So again, we're looking at the four operations: addition, subtraction, multiplication, and division. Right. But before we do so, how do decimals arrive? Where do they come from? Why do we need them? Well, they come from calculations like this. What is 24 divided by 10? Now, you may have been taught at primary school, when you divide by 10, you move the decimal point that was hidden one to the left. So the answer is 2.4, which is a decimal. A decimal number is one that has a decimal point. How else might they arrive? They might arrive through multiplication. Here we go, 1.648 times 100. Now, you might have been taught at primary school or prep school that when you multiply by 100, you move any decimal point 2 places to the right. So the answer would be, that's where our new decimal point is, 164.8, which is again a decimal number because it has a decimal point. Right, now let's look at adding and subtracting them. Here we go. We're going to add 4.3 and 1.27. Now, it's slightly different from our addition of integers. What we do here is we line up the decimal points. So then we've got 4.3, and then underneath it we write 1.27. So the key thing when you're adding and, as you'll see, subtracting decimals is line up the decimal point. And before you do any work, put a decimal point directly underneath the other decimal points in your answer line. Now watch what I do. 7 add nothing is 7. 3 add 2 is 5. 4 add 1 is 5. Then put a line underneath, if we'd like to be neat, to give us the answer 5.57. So the key is line up the decimal points. Let's look at subtraction involving decimals. Here we go. Let's just get rid of this. 5.1 take away 2.84. So let's put the decimal points that we're going to need. So it's 5.1, and then underneath it 2.84. Put the minus sign there. Let's put a line here to show we're doing the working. Now, when it comes to subtraction, if you haven't got figures above each other, then we have to fill out the figures. So I'm going to have to put a 0 here so they've got the same number of figures after the decimal point in both numbers. Now watch what I do. I do 4 take away 0. You can't do. So I've got to borrow from this 1 here. So that goes down to 0, and I put a 1 there. Then I do 10 take away 4 is 6. Oh, what did I forget? Dreadful of me, wasn't it? I should have had a decimal point here in the answer row. Now let's go back to it. 8 take away 0. Again, you can't do. So I borrow from the next figure to the left, that 5 there, which goes down to 4, and I put a 1 in front of that 0. Then I do 10 take away 8 is 2, and 4 take away 2 is 2. So our answer is 2.26. And you can double check, because this number here that we were subtracting, 2.84, plus our answer, these 2 must add up to 5.1. So let's just double check. 2.84 and 2.26. Put the decimal point there. 4 add 6 is 10. Put 0 there, carry the 1. 8 add 2 is 10. Add the carry 1 is 11. Put 1 there, carry the 1. 2 add 2 is 4. Add 1, 5. Well, it doesn't look the same, but it is. 5.1 nothing is the same as 5.10. Okay. Now let's look at multiplication. 3.4 times 1.2. Now watch what I do here. Multiplication's different. We ignore the decimal point to begin with. So I do 34 times 12. No decimal points appear. Now watch what I do. So I'm going to multiply everything on the top row, every figure on the top row by 2. So I do 2 times 4, which is 8. Then I do 2 times 3, which is 6. Next I'm going to multiply by this 1 here, but it's in the tens column. So I start with a 0 down before I do any multiplication. Then I do once times 4 is 4, and once times 3, which is 3. Then I add them up, and we get 8 add 0 is 8, 6 add 4 is 10, put 0 there, carry the 1, nothing add 3 is 3, add the 1 is 4. So there's the answer. Well, not quite. Because what I have to do now is put the decimal point into my answer. I know there's a decimal point because the numbers I was multiplying had decimal points. Now the way to work out where the decimal point goes is you count the number of figures in the question that are after the decimal point. Well, we've got 2 figures after the decimal point in our question, so our answer needs 2 figures. So our answer is 4.08. Right, and finally, let's look, when we're looking at decimals, let's look at division. Here we go. We're going to work out 4.85 divided by 4. So we draw our bus shelter. We put the number we're dividing inside it. We put the number we're dividing by outside it. But before we do anything more, I'd line up a decimal point in my top row, the one above the bus shelter, so that the decimal points are in line. Then I do my division as normal. 4s into 4 go 1, no remainder. 4s into 8 go 2, no remainder. 4s into 5 go 1, remainder 1. Now, here's where it's different. After the decimal point, after the last significant figure, I'll explain that later on, you can have as many zeros as you want. I could, if I needed, go on and on to the right. I probably won't need these. But what I do is I put a 0 in the empty square there, and then I do 4s into 10. 4s into 10 go twice, remainder 2. Whoops, I'm going to need another 0, aren't I? Put 2 there. And then let's just make this bus shelter a bit longer. 4s into 20 go 5. So there's our answer. 485 divided by 4 is 1.2125. Right. Now, let's look at decimals. We're going to look at fractions next. Where do we get fractions from? Well, we get fractions from these sort of divisions. And fractions are brilliant. They make division so easy. 9 divided by 11 is 9 over 11. Let's look at another way we could get a fraction. 3 divided by 2 equals, you got it, 3 over 2. Now, how do we add and subtract and multiply fractions? Notice I've left out division because that comes in, it's a grade D topic. Right, adding fractions. Here we go. 3/8 add 2/8 equals. It's easy when the denominators, that's the bottom part of the fraction, the bottom number in the fraction, are the same. 3/8 add 2/8 is 5/8. Notice the denominator doesn't change, though the numerator, that's the top number, is got by adding 3/2. It's the same with subtraction. Let's look at a subtraction. Here we go. 4/7 take away 1/7. Notice that the denominators are the same. In fact, you could write your part of your answer by putting a line here and a 7, because you know the denominator is going to be 7. It doesn't change. Then to find the numerator, the top part of our answer, you do 4 take away 1, which is 3. Multiplication, even easier. Here we go. 2/3 times 1/5 equals. It doesn't matter with multiplication whether the denominators are the same or not. It doesn't matter. All we do is 2 separate multiplications to work out the top part, our numerator, 2 times 1, which is 2, and then another multiplication of the denominators, and 3 times 5 is 15. Very simple. Okay, now the last thing that I want to look at are ratios. Now, how do we get them? Well, we get them when we compare two things. Let's have a look. Let's imagine that in a class there are 17 boys and 15 girls. What's the ratio of boys to girls? Well, it's as simple as that. There are 17 to 15. We use this symbol here, the colon, to replace the word to. What's the ratio of girls to boys? The ratio of girls to boys is there are 15 girls to 17 boys. The order's changed, that's all. Okay, right, so that's the basics. Let's just go back to the top and look at what we covered. We covered the basics, mainly addition, subtraction, multiplication and division of integers, of negative directed numbers, decimals, fractions and ratios. What I haven't looked at yet are indices, roots and BIDMAS. What are they? Well, let's look at a number that has an index, 5 to the power 2. This number here is the first one we pronounce. We pronounce it as 5, and then to the power or index of 2. And what it means is this: it's our shorthand for writing 5 times itself. What about 4 to the power 3? 4 to the power or index 3. Well, that means 4 times itself times itself. It appears 3 times, the same as the index. So I'm sure you can work out what 7 to the power of, or let's say 5 is. 7 to the power multiplied by itself 5 times. So it's 7 times 7 times 7 times 7 times 7. Roots, what are they? Well, the main one you're going to be interested in at grade D is this one here, the symbol here, the square root of 25. What they're after you doing, working out is what number times itself, that is squared, equals 25, and the answer is 5. So the square root of 25 is 5, because 5 times 5 equals 25, or using index notation, 5 squared equals 25. Let's look at that again. Let's say you were after the square root of, a larger number now. Let's go for 64. So what number times itself gives us 64? The answer is 8. Why? Because 8 times 8, 8 times itself equals 64. Or using index notation, 8 squared is 64. Now, in the exam, you might be asked to work out something like this. Here we go, 6 to the power 3. They're after a bit more than you just writing it out. Here's how you work it out in a non-calculator paper. You do 6 times 6, which you should know from your 6 times table, or your times tables, is 36. And then we use long multiplication, unless we're quite gifted, to work out what 36, which is 6 times 6, is equal to. 6 times 6 is 36, put 6 there, carry the 3. 6 times 3 is 18, add the 3, 21. So the answer is 216. And finally, BIDMAS. We use BIDMAS when we've got more than one calculation going on, more than one operation. Here, I'll give you an example. 7 plus 4 times 3. Let's look at this BIDMAS and what the letters stand for. B stands for brackets. Always do those first. Then I stands for indices or powers. We just looked at those. D and M stand for dividing and multiplying. And A and S stand for adding and subtracting. And it's the order in which we do things. We do brackets first, then indices or powers, then dividing and multiplying, and then adding and subtracting. So here, if we look, we've got a multiplication, whoops-a-daisy. We've got a multiplication and an adding and an addition. We do the multiplication first, so it would be 7 add 12. And then, of course, 7 add 12 is 19. Let's go through that again. Let's say we had 4 times 3 plus 5. Now normally we would do this multiplication first, but brackets come before everything. So we work out the brackets first, so it would be 4 times 8 equal to 32. So BIDMAS tells us the order in which we do things. Right. So they are the basics. Now let's move on. Changing numbers. Now, there's 3 ways we change numbers, and we'll look to see later on why we do that. Rounding. Rounding. So you've got a large number like this, and you don't need, or for whatever reason, you don't need to be that precise. We can round it to the nearest 10, and the way we do that is this. We put an arrow above the figure in the tens column, and then we get rid of that and replace it with a 0, and then we ask ourselves, do I make this 4 one bigger or not? Well, The rule is this: if the figure you crossed out, the first figure you crossed out, was 5 or more, which it is in this case, you make the figure you keep, this one here, the last figure you keep, 1 higher. So to the nearest 10, that is 7,150. Let's go through that again. Here we go, 6,349. And we're going to round this to the nearest 100. So I put an arrow above the figure in the hundreds column. I get rid of all the others. But I ask myself, do I make this 3, my mistake, 1 bigger? Well, let's have a look. What was the first figure I crossed out? The first figure I crossed out was a 4. So this 3 doesn't change. So I write it as 6, 3, and then remember, for each figure you cross out, you replace them with zeros. So to the nearest 100, it's 6,300. Let's look at rounding decimals, because very often we don't need all the figures on our calculator display or in our calculation. We're going to round that to 1 decimal place. So put an arrow above the last figure you're keeping. That's the first figure in the decimal place. Cross out all the others. Now, ask yourself, do I make that 1 that I keep bigger? Well, let's look at the first figure I crossed out. It was a 4 again. If the first figure you cross out is 4 or less, you don't change the figure you keep, the last figure you keep. So that becomes 7.1. Now, when we rounded whole numbers, we replaced the ones we crossed out with zeros. And you could do that. But with numbers with a decimal, strings of zeros after the last significant figure aren't of any importance. So we just ignore those. Right, there's one other bit of rounding we need to know, and that's this. We're going to round to 1 significant or important figure. Will I fit that on? I did. 1 significant figure means you round it to the first whole number in your number. The first figure, not whole number, the first figure in your number that isn't a 0. So we're going to round it to the first figure. So I'm going to get rid of those, and I get, oh, do I make the 7 bigger? Let's have a look. No, I crossed out a 1, so it remains 7, and replace the figures I crossed out with 0, 700 to 1 significant figure. This one here. The first significant figure is a 4. So I cross out all the figures to the right. Let's have a look. Do I make that 4 bigger? Well, let's inspect the first figure I crossed out. It was a 9. Yeah. So remember the rule, if it's 5 or more, the last figure you keep goes up by 1. So that's going to be move up to 5. And then I replace the figures I crossed out with 0. Okay, now, changing fractions. Right, now it gets a bit more complex. What do I mean by changing fractions? Well, look at this fraction here, 9/12. I can change that, and I'm going to change it by dividing top and bottom by the same number, by a common factor. Remember, a factor is a number that divides in exactly without remainder. The common factor here is 3. So we divide 9 and 12 by 3 to get 3 over 4. Making the denominator and numerator smaller by dividing by a common factor is called simplifying. You're making your fraction smaller. Simplifying. Let's go through that again. Here we go. Here's our fraction, 15 over 25. Now I want to simplify that. So what's the common factor of 15 and 25? 5 will divide into both 15 and into 25. 5 is a factor of 15 and 25. So divide top and bottom by 5 to get 3/5. Again, I've simplified it. The numerator and denominator are smaller. One last example at simplifying. 30 over 70. Well, we've got quite a few common factors. I could divide top and bottom by 2. They're both even. Or by 5. But I go for dividing by 10. I always go for the highest common factor. So I'm going to divide 30 and 70 by 10 to give me 3/7. That's called simplifying. Other times, though, you might need to work in the opposite direction. Here we go. I want to make 4/7 equal to something, oh sorry, equal to 12 over something. What do we do here? Well, we ask ourselves, what if I multiplied 4 by 3? So if I multiply the denominator, the 7, by 3, it remains an equivalent fraction. They both, numerator and denominator, have been multiplied by the same number. It's the same reasoning as when we divided top and bottom by the same number, when we cancelled down and simplified. Just go through that again. Here we go. We want to make 2/5 equal to something over 30. What do I multiply 5 by? I've multiplied it by 6, so I have to do the same to make sure it's an equivalent fraction to the numerator to give me 12 over 30. Why do we do such a thing? Well, we do it when we want to compare fractions, and also when we want to add them. Right, let's look at comparing fractions. I've got, sorry, crossed out both there, 1/3 and 1/5. Which is bigger? Oh, sorry, make that 2/5. It's fairly obvious that 1/5 is smaller. Which is the smaller now? Well, you can't compare them when they've got different denominators. So what we do is we put them all over the same denominator, and we find that denominator by multiplying those two together. I'm going to put them both over 15. Now, what's happened here? I've multiplied the 3 by 5, so to make sure it's the same, the equivalent fraction, I multiply the top, the numerator, by 5. So 1/3 is 5/15. What about 2/5? I've multiplied the denominator by 3, so I have to do the same to the numerator. So it becomes 6. I don't know where the plus sign came from. 15ths. Now we can compare them. Which is bigger, 5/15 or 6/15? Well, the answer is 6/15. So, going back to our original, the larger of the two fractions with 2/5. Let's look at, I mentioned about addition. Let's look at where we've got some fractions we want to add, but they've got different denominators. Remember, if you go back to our basics, you had to have the same denominator in order to add or subtract. So what we have to do is make sure they have the same denominator. And what I'm going to do is I'm going to make them both over 9. Why 9? Well, 3 will go into 9. 3 is a factor of 9. So what I've got here is 1/9 is 1/9. But what about the 2/3? How many ninths is that? Well, I've multiplied the denominator by 3. So I must do the same to the numerator to give me 6/9. 6/9 plus 1/9 is 7/9. Just look at subtraction involving fractions. Here we go. 2/5 take away 1/20. Well, I'm going to make both my fractions equal to 20ths. That's the larger one, isn't it? Now, all right, 1/20 doesn't need to be changed. But what about 2/5? Well, I've multiplied the denominator by 4, so I have to do the same to the numerator to give me 8/20. Take away 1/20, which is 7/20. Now, finally changing numbers, we'll look at ratios. Let's say we had the ratio 70 to 110. You might be asked to simplify this ratio. Well, how do we do that? Well, we look for a common factor, a whole number that will divide exactly into both. In fact, we look for the largest one. 10 will divide into both to give us 7 to 11. Yep, 70 to 110 simplifies as 7 to 11. Let's go through that once more, again looking at ratios. Here we go, a far simpler one, 4 to 10. We're going to simplify this. What's the highest common factor? 2 will go into both parts of the ratio. So it becomes 2 to 5. Okay, so let's just reiterate then. We've looked in this part of the video at changing numbers. We've looked at rounding, how we can perhaps don't need the precision of a number, and we can round it to the nearest 10 or 100, or to one decimal place, or, quite importantly, to one significant figure. We also looked at changing fractions, how we make sure that they remain equivalent, and we do that by dividing or multiplying the denominator by the same factor. And we looked at changing ratios, where we do something similar to what we're doing with fractions, dividing by a common factor. Now, the last part of this video, we're going to look at contextual problems. This is the longest video of the grade E ones because the number part is such a significant part of grade E maths. Estimates. Here we go. Estimate 48 times 712. Now watch what I do. I round both numbers to one significant figure. So 48, that rounds to, well, let's have a look. I'm going to keep that 4, I'm going to get rid of that 8. But because the 8 was more than 4, I'm going to make this figure here, the 4, one bigger. So it becomes 50. Times again, I'm going to round this number 712 to one significant figure. So I'm going to get rid of those. Do I make the 7 one bigger? Do I turn it into 8? The answer is no, because the first figure I crossed out was 1. So that becomes 700. And now all I do is this. 5 times 7, 35. And then, let's look at the question. It's got 3 zeros, so my answer has 3 zeros. So the answer is 35,000. Look at one more estimate. Estimate 613 divided by 34. Well, I start as before. I'm going to round these to one significant figure. So I'm going to get rid of those. Do I make the 6 bigger? Do I turn it into 7? Well, the answer is no, because I crossed out a 1 first. So that remains as 600 when rounded. Oh, that goes to 600 when rounded one significant figure. What about 34? Let's have a look. Oh, I got rid of a 4 there, so the 3 doesn't change, it remains 3. So it's 600 divided by 30. Now, I don't know if you were taught this, when dividing by numbers that have zeros, non-decimal numbers that have zeros, we can cross off 1 0 in the dividing number and 1 0 in the number we're dividing, and it remains the same. So 600 divided by 30 is the same as 60 divided by 3, which is 20. Now, of problems, nice and straightforward. You might be asked to find 2/5 of, here we go, 38. Now, the good news is you can use a calculator. We type in 2/5. And that's what I did. I pressed 2, then the fraction button, and then 5. Then, just move the cursor just to the right. The word of in maths is the same as times. If it helps you, cross out the word of and replace it with times. So I do 2/5 times 38, and there's my answer. Now it's come up as an improper fraction. If we press the standard to decimal button, it becomes 15.2. It's the same with percentages. Let's have a look. 36% of 74.81 pounds. The word of in maths can be crossed out and replaced with the word times. Let's just go through that. Now 36%. You type in 36 and then find the percent button. Then we do times 74.81, and there's our answer, 29.316. Let's just double check the old memory goes. 9316. It does go quickly, doesn't it? Now we can use rounding here. Let's round that to 2 decimal places. So I put a figure above the, an arrow above the second figure after the decimal point. Get rid of all the others. Do I make the 3 one bigger? Let's have a look. Now I crossed out a 1 first. So my answer is 29.93, and then show that you've rounded it 2 decimal places. Right, we're getting there. Don't worry, there's not much more of this. Now, more contextual problems. we're going to look at the final part of the video at contextual problems. Contextual problems are ones where the maths is given to you, or the problem's presented to you in words, and you've got to work out what the arithmetic, you need to use. And they come under various headings, or I've decided they come under these headings: money problems, proportion, best buy, deposits, simple interest. Let's look at what I mean by a money problem. Well, actually, it's a proportion problem. John buys 12 pencils for £1.80. How much does one pencil cost? All those words there. What does it boil down to in arithmetic? He's got 12 pencils for £1.80. How much would one pencil cost? Now you've got to ask yourself, is it add, subtract, multiply, divide? Well, if 12 lots cost £1.80, one lot's going to cost a smaller amount. And it's in proportion. So instead of being taken away, you divide. Any proportion problem is a multiply or divide. So what we do is this. We divide £1.80 by 12 to find the cost of one. Now, if you're fortunate, it'll come up in a calculator paper. If not, well, we'll have to go back to one of the techniques I taught you earlier. We're going to divide 1.80 by 12. So remember, put your decimal point here. Now, 12's into 1. Go 0. 12 won't fit into 1, but there's one remainder. 12's into 18. 12 goes into 18 once, and the remainder is 6. 12's into 60, go 5. So the answer is 0.15 pounds. Or, converting pounds to pence, 15 pence. Let's look at another contextual problem. This is a money problem. Duncan gets £4.20 a week pocket money. He saves this for 5 weeks. He then buys some flowers for his mother that cost £12.60. How much does he have left? We've got to work out what arithmetic to do. 5 weeks he saves £4.20, so it's going to be 5 times £4.20 to work out his savings. So we're going to do 5 times 4.20. Now here's a trick or a tip when it comes to multiplication. Always put the larger number on the top. It makes life easier. Multiplication, the order doesn't matter. So remember, when we multiply decimals, we ignore the decimal point. So what should I do? 5 times 0 is 0. 5 times 2 is 10. Put 0 there, carry the 1. I haven't set this out very well, have I? I've not given you some, should be teaching you good habits. So 5 times 0 is 0. 5 times 2 is 10. Put 0 there, carry the 1. 5 times 4 is 20. Add the 1, 21. Whoops, daisy. So my answer is 2100. Oh, how many figures have I got after the decimal point? In the question I had 2. So my answer needs 2 figures. So the answer is 21.00 pounds. Now, what else is happening? He buys some flowers for his mother that cost £12.60. How much does he have left? Do I add the £12.60 or do I take it away? Well, it's money that he's spent, so it's going to be taken away from the £12. So here's what I do. I then take away 12.60. Notice how I've lined up the decimal points. Put a decimal point here in your answer line. Then we do 0 take away 0 is 0. Then 6 take away 0. Well, you can't do with this method, so I have to borrow. So that 1 goes down to 0, and I put a 1 there. So it's 10 take away 6 is 4. Then it's 0 take away 2. Again, I can't do that, so I borrow. So that goes down to 1, and I put a 1 in front of the 0. 10 take away 2 is 8. And then 1 take away 1 is nothing, or 0. We tend to leave 0 if it's the first figure. We just ignore it. And then I write clearly my answer, including the units. He has £8.40 left. Right, now, here's a more involved one. John wants to buy a new cooker. The deals available are new Zusi cooker, £250, autumn sales reduction 20%. Or a new Zenon cooker, £50 deposit plus 12 monthly payments, £15. Which is cheaper and by how much? How do you set out your work? Well, we're going to work out the cost of each of these. So, set out your work like this. So the examiner or any other reader can tell what you're doing. We're going to work out the cost of the Zusi first. So, 20% reduction. What does that mean? It means 20% is being taken off. So first we work out what 10% of £250 is. Now in a non-calculated paper you'll only get percentages like this. The way to find 10% is to cross off 1 0 of the number you're reducing, or find the percentage of. So 10% of 250 is 25. So 20%, I'll use the ditto marks here, must be double that, 50. So then I'm going to work, that's the amount, this £50, that's taken away. It's the price is reduced by £50. So I do 250, take away 50, equals £200. And underline it. That's the cost of the ZCSE. Now, so just pause this. Now what else were we asked to find out? Oh, we've got to find out the cost of the Xenon cooker. It's £50 deposit plus 12 monthly payments of £15. So here's what we do. We write Xenon. We know the cost is £50. We have to pay that. Plus 12 times, let's remind ourselves, what was it? £15. So I'm going to work out 12 times 15. I'll do it over here. Whoops, I did say always put the larger number on top. So we're going to put 15 here and 12. Now what will I do? Start with this, the rightmost number and the rightmost figure and the bottom number. 2 times 5 is 10. 2 times 1 is 2. Add the carried 1 is 3. Now I'm going to multiply by the 1. But the 1's in the tens column, so remember to start with writing down a 0 before you do any multiplication. Then once times 5 is 5, and once times 1 is 1. Then I add them up. What do I get? 180. So I've now got to add up the £50, that was my deposit, plus the 180. I haven't set this out very well. 0 add 0 is 0, 8 add 5 is 13, 1 add the carried 1 is 2. Now I better write that down clearly, £230. Yeah, my work was a bit all over the place really. That's why I underlined it, so that the examiner, okay, he won't necessarily work back and see all you're working. He'll just spot that you've written down clearly 230. Now, so I've got the cost of both the Xenon cooker and the ZCSE. But the question, don't lose the marks in the exam. Which is cheaper, and this important bit here, by how much? What's the difference? Well, the difference is £30. So write it clearly. The difference, how much one is cheaper than the other, is £30. How did I get that? I got that by looking at 230 and 200. I took the 200 away from the 230. The next one we're going to look at is a best buy problem. Kevin has a choice of 2 pots of paint, a 6 litre pot at £3.96 or a 5 litre pot at £3.55. Which is the better buy? How do you go about these? Better buy, what they're talking about? Well, we work out the cost of 1 litre for each pot. So, what does it cost to buy 1 litre of paint if you buy a pot of 6 litres? Well, remember that pencil question? If 6 litres costs £3.96, how much does 1 litre cost? We do 3.96 divided by 6, and we use long division here, or as the Americans would call it, short division. So put 396 in the bus shelter, 6 outside, and put 6 there. 6 is, sorry, not 6 there, a decimal point. 6 and a 3 go 0, won't go in because 6 is bigger, remainder 3. 6 and a 39 goes 6, remainder 3. 6 and a 36 go 6 times. So the answer is £0.66, or 66 pence. What about for the 5 litre one? Same thing. We work out the cost of 1 litre. So if 5 litres cost £3.55, to work out the cost of 1 litre, we divide. So, our bus shelter here, put the number we're dividing inside it, and the number we're dividing by outside it, and a decimal point directly above, in the answer row, directly above the decimal point in the number we're dividing. 5's into 3. Again, go 0 times. 5's bigger than 3. And remainder 3. 5's into 35. Go 7 times. No remainder. 5's into 5. Go 1. So 1 litre costs 0.71 pounds or 71 pence. So which is the better buy? You have to write this clearly. The better buy is the 6 litre pot. Why? It is cheaper per litre. What's cheaper for each litre? Only costs you 66 pence for each litre of paint as opposed to 71. Now the last one, you'll be relieved to hear, is we're going to look at simple interest. Again, a contextual problem where we have to use our arithmetic. James invests some money at 4% per annum simple interest. He invests £500 for 6 years. How much interest does he get in total? What's all this about? Well, when you lend money, you invest it, okay, you get interest on it. You get a payment for having lent it, and it's based normally as a percentage. This is, in this instance, it's 4% per annum. That means per annum means for each year. So he gets 4% for each year. He invests it for 6 years. So he's going to get 4% for each year, so it's times 6. He's going to get 24% interest. So all we have to do here is we have to work out what is 24% of his investment. What is 24% of 500? So you write 24% of £500, and you thank your lucky stars. It comes up in the calculator paper. Now remember the word of we can cross out and replace with times. So all we do is this: 24 shift percent times 500, and there we have it. His interest is £120. That's how much he gets for just having lent that money for 6 years, for being unable to use it. Okay, it's been long. This is it though. If you can get the arithmetic, the number work here under your belt, if you know most of these topics or eventually get to know them, okay, a grade E is definitely achievable, well, almost definite. And of course, with the way the GCSEs in England are worked out, getting every grade E or below question right, okay, can get you a grade D. So if you can get up to the same standard with your algebra, and there isn't so much of that at grade E, and your data handling, probability, and your shape, space and measure, then you can be looking at a good grade E or a grade D. Of course, we want better than that, so there's a later videos we'll be looking at grade D maths, which builds on the grade E one, and grade C, which is, for most of us, I imagine, that are watching this video, our personal target at the very least. Okay, thank you for listening.